I can get through this video without hacking and gacking and coughing and all the things. I don't know. Well, it's on the Google Classroom last year's. So Colin and Hunter and Caleb is who we're recording for, and I have no idea. Maybe somebody out of the 5th period class. I don't know if they're gone. But we're doing angle relationships. They wanted to stop and do a whiteboard day, and I said, "Oh, can we sneak angle relationships in there first?" Because this is not a terrible section. Really, 2-3 does kind of switch gears, and we do to like 2-dimensional figures. So after this section, we're kind of done with angles for a little bit. Then we switch to something completely different, which is kind of weird, but whatever. All right, let's go complementary and supplementary angles. You've heard those before. What are they? They're angle pairs, so 2 angles are complementary if they add up to be 90 degrees. So if one angle is 42, the other one has to be 48. Right? 42 and 48 are complementary angles. 81 and 9 degrees, those are complementary angles. Any 2 angles that add up to be 90 degrees, okay? Supplementary, they add up to be
180.
180. So 120 and 60 degrees are supplementary angles. 151 and 29, those are supplementary angles. How do you keep them straight? How do you remember that which one is 90 and which one is 180? You want to know how I know? I do it really stupid. 90 comes before 180 numerically.
And
C comes before S in the alphabet.
Dang.
Yeah, like seriously, that's so dumb, but that's how I do it, right? Complementary comes first before supplementary in the alphabet, so 90 comes first. 90 is complementary, supplementary is 180. Whatever. Okay, now, also along this supplementary angles little tidbit, yesterday, or Friday, I guess, we talked about a linear pair. Right? Do you remember what a linear pair was? You have a straight line and an angle off of him, and these 2 angles are a linear pair. Those 2 angles are supplementary, right? Linear pair, 2 angles that form a linear pair, form a straight line, are always supplementary, right? Got it? So they might use some of those words in there too. All right, here we go. We have examples. Like this guy over here is 30 and this guy over here is 60.
Yeah.
Here's the deal. Complementary angles and supplementary angles do not have to be touching each other in order to be complementary or supplementary. These 2 angles are completely opposite each other. Now, the 2 angles have to be touching each other to be a linear pair. True? But they do not in order to be supplementary, right? Like down here we have, that didn't work. Right here we have supplementary angles, 110 and 70. Those are supplementary. Those are not a linear pair though, because they're not both together on a straight line. What about the ones right below it? Are those supplementary? They add up to be 180? Are they a linear pair?
Yes.
Yes, they are, right? Because they touch each other. They're adjacent, right? Okay? So there is that. This one is complementary that are touching, right? But they don't have to touch in order to be complementary. They don't have to touch in order to be supplementary. Got it? Okay. All right, here we go. We have a story problem. Example 1. Find the measures of 2 complementary angles. Woo! What should we name our angles? Fred and Jeff, F and J. Okay, those are the name of our 2 complementary angles. What do we know about this 2? What do we know about Fred and Jeff? Fred plus Jeff equals 90. I haven't even read like the whole first sentence. Find the measures of 2 complementary angles. Boop. Okay, Fred plus Jeff equals 90. If the measure of the larger angle, which one's bigger, Fred or Jeff?
Jeff.
Jeff is bigger. Jeff is equal to, the larger angle is 5 more than 4 times the smaller angle. What is 5 more than 4 times? 4x plus 5, but we call the smaller one Fred, right? So Jeff is the bigger one, and we have to take 4 times Fred and add 5 to get how big Jeff is, right? Got it? Fred, Jeff. Okay, so we got these 2 equations going on here. Now what do I do?
Find F.
But we
What?
don't know what J is.
We don't know what J is.
And we don't know
So both of these equations involve 2 variables. I have to get them so that I only have 1 variable.
So put them together.
Put them together. I know that Jeff is this much, right? So I'm going to take this Jeff, and I'm going to take this, and I'm going to plug him in there. That is the process of substitution. Yeah? Have you heard substitution before? Okay, so now this guy, Fred, is just staying over here. He's just F plus, but now this guy gets plopped in there, right? 4F plus 5. That got plopped in there for J. Equals 90. Yeah? Okay? All right, now let's simplify. What do we got? 5F. I'm going to subtract the 5 over to the other side. Can I do that? Equals 85, and then divide by 5. So Fred is 117. Can you do that in your head? Try. 85 divided by 5. 8 divided by 5 is 1 with 3 left over. So then you have 35, and that's 7.
Yup.
Yeah?
Yup.
Okay. So Fred is 17 degrees. Okay. Now, I know that Fred and Jeff add up to be 90, right? Fred plus Jeff is 90. So I could plug that in there, right? Fred is 17. So then I subtract and figure out what Jeff is. They add up to be 90. That is 72 degrees. 73 degrees. I cannot math. 73 degrees. There you go. And those two add up to be 90. Do you see what I just did?
Yeah.
Yeah, yeah?
A lot of math.
A lot of math. Shall we do the check also?
Yes.
Yep.
Okay, let's do the check because those ones are weird. And we don't have very many examples to begin with. All right. The difference between the measures of two supplementary angles. Hold up. What are my supplementary angles called? What should we call them? Let's give them a name.
Jerry's.
What?
Deborah.
I need 2 names. What?
Jerry's.
Bob and Deborah.
Jerry and
Bob
Tom.
and Deborah. Bob plus Deborah equals how much? 180 because they're supplementary, right? Okay. We know that if they're supplementary that Bob plus, and I haven't even got through the first sentence yet, but I have 2 angles and they have to add up to be 180, right? Because they're supplementary. All right. The measure, and it says the difference between the 2 measures is 18 degrees. Woo, okay, so B minus D equals 18. Which one's bigger in that case? 18. Bob is bigger than Deborah, right? Okay, the difference between them is 18 degrees. So now I have my 2 angles. Okay. What shall we do?
Equals, B plus 18 equals, D plus 18 equals B, and then could we substitute?
Sure, we can. All right, so this is what Caden wants to do. He's rewriting this equation. He's adding the D to the other side. I think you added B. So B is equal to D plus 18. Yeah, if we add the D over to the other side. Okay, then I can take D plus 18 and I can plug it in right here for this B. Got it? So what's my top equation going to look like?
2D plus 18.
I got D plus 18 plus this other D, right? This is what I plugged in. Equals 180. Are we lost?
No.
You see what I just did?
Kind of.
Yeah?
162 equals
Yeah, we're good?
Substitute.
We're good? I just plugged it in. So what's D plus another D?
2D.
2D. And I'm going to subtract this 18 to the other side. Equals 162.
92.
Divide by 2
81.
is 81. D is 81. Okay? But I know that B and D have to add up to be 180. What's 180 minus 81?
99.
99 degrees. All right, I'm going to show you a shortcut. Boop. Ready? Go back to this equation right here. We have 2 different ways of solving 2 variable equations, by the way. One of them is substitution, which we did. The other one is called elimination, right? Do you remember the elimination method? Where you take the 2 equations and you add them together and you eliminate a variable, right? This one is one where I would most certainly do elimination. Yeah?
D.
Because what is B plus B?
2B.
2B. But what's D minus D?
0.
Goes away. Equals 180 plus 18, 198. Divide by 2, and that is 99. So in that case, I'm solving for B first. But that one is a really nice one where I set up so that I can eliminate the variable, right? Yeah, for like a second. Why? Oh, sure. Sure, that's fine. Just come back in like 5 minutes. Okay? And then we plug that in that way. Okay? So you can do substitution, which is what we did, or you could do elimination, right? Which may have been easier in that case.
About time.
Got it? So the measure of the smaller angle, which we called Deborah, is 81 degrees, and the measure of the larger angle is 99, which we called Bob. Okay. All right, good? Beautiful. Okay, perpendicular lines. Do we know what perpendicular lines are? Let's back up. Do we know what parallel lines are?
Yeah.
They don't intersect.
Parallel, don't intersect. They go like this, whoop, or like this, whoop, or like this, whoop. Anything like that, right? Those are parallel. Perpendicular are going to intersect, but they intersect at a special way.
Do they make 90?
These are not perpendicular lines. Yes, they make 90 degrees when they intersect. They make a perfect T. So each one of these is a 90-degree angle. Yeah, yeah? Okay? So perpendicular lines have to intersect at a perfect T. Got it? Okay, so let's go down here. It says perpendicular lines form 4 right angles. What they will do for perpendicular lines when they show them to you is they will only put usually a box in one corner. But that means that
They're all.
all of them are boxes, true? They just do it in one corner so it's just a little less messy. But you kind of have to infer that all of them are 90 then, right? And 90 plus 90 plus 90 plus 90 adds up to be
180?
No.
Oh, wait, no.
360, because that's a full circle, right? Okay? All right, perpendicular lines intersect to form congruent adjacent angles. Okay, let's talk about that. Congruent adjacent angles. Like this angle and this angle are adjacent because they share a vertex and they share a side. Are those two angles congruent? What does congruent mean? The same. Are those two angles the same?
Yeah.
They're adjacent and they're the same because they're both 90, right? Now, aren't this angle and this angle also adjacent?
No.
Don't they share a vertex and a side?
Yeah.
Yeah, they're adjacent as well, right? These two are adjacent. Are they congruent?
Yeah.
Yeah, they both would be 90, right? Because even though they don't put a box in that corner, it's got to be 90, right? Okay. Are these two adjacent?
Yeah.
Yeah, because they share this vertex and side, right? Are they congruent?
Yeah.
Yes, because even though they don't put a box there, it's going to be 90, right? Congruent adjacent angles. All right, perpendicular lines. The tangram is a puzzle consisting of 8 flat shapes called tans, which are put together to form images. Find the measure of x and y such that, here we go, AD, which is this guy, whoop, and CE are perpendicular. Okay. AD and CE are perpendicular. This guy and this guy are perpendicular lines, which means this is 90, this is 90, this is 90, this is 90. Right? All right, what should we do? Should we solve for x or y? I got 2 x's, which are up here. And I got 1 y that's down here. What should we do first? Do you want to solve for x? Okay. All right. They split this angle into 2, like here and here, right? But I don't necessarily know that this guy is equal to this guy, right? We can't set them equal. But what do we know about the left side and the right side?
There are 2 halves.
But we don't know that they're half, though. What?
Can we add them?
Can we add them? What are they equal to if we add them?
That's straight. 1.
Yeah, what's this angle right here?
90.
90. They're equal to 90 degrees, right? Okay. So the small one angle is 7x plus 10. I don't necessarily know that that's a smaller one. 8x plus 5 is equal to 90, right? Okay. So if I add them together, they equal 90. 7x and 8x is 15x. 10 plus 5 is also 15 equals 90, right? I'm going to subtract my 15 over. 15x equals 75 and divide by 15, and that is, I think, 5, right?
Oh, yeah.
X equals 5. Are we trying to solve for anything? Whoop. Find the values of x and y. There's x. Yeah, yeah? Okay? All right. Don't necessarily set those equal to each other because we don't necessarily know that the both of those are 45 degrees, right? What about 3y plus 15? They have that only like
Equals.
one of, yeah, that whole thing equals 90, right? Yeah, just by himself he equals 90 because he is that angle, right? Are we following along? Are we doing okay?
3y.
If I subtract 15,
Y equals 45.
3y equals 75 and divide by 3 and y is 25. Okay. Good, good? Yeah, yeah? All right, do we see how this works? Are we doing okay?
Yeah.
Okay. That was number 2. What was what? Never mind. Okay. All right. When we are looking at diagrams, there are some things that we can assume to be true and some things that we cannot assume to be true. So let's look at this diagram right here in the middle and this guy. Okay, focus your attention on this guy. I am going to talk about things that we can assume to be true. So it says all points and lines are coplanar, which means they're on a flat surface, which means that this guy right here is not like poking out of the thing, right? Everything else is laying flat, like L is not elevated above. You know what I'm talking about? They're all like flat on that flat surface. That is something that we can assume to be true, right? We can assume that G, H, and J are making a straight line, but they are collinear. Does that look like a straight line?
Yeah.
We can assume that, right? We can assume that makes a straight line, all right? We can assume that H is between G and J, that H is in the middle from G to J. We can assume that, okay? Now, can we assume that H is exactly in the middle and he is the midpoint? No, unless they do this to us where they put those little tick marks. We do not know that he's exactly in the middle. That's going to be probably on down here below. Cannot be assumed, right? We cannot assume that he's the midpoint, okay? All right, we can assume that L is in the interior of MHK. MHK, this angle right here, that L is inside of that little chomper. Yes, we can assume that. All right? These are all things that we are allowed to assume. We can assume that GHM, this guy here, and MHL, these guys here, so this angle and this angle are adjacent because they share a side and a vertex, right? Those two are adjacent angles. We can assume that, all right, from the diagram. We can assume that GHL, this angle, and this pink one, not that pink one, this pink one, that those are a linear pair because they live on a straight line right here, right? So given that, if they give me this angle measure and they give me this angle measure, those would add up to be 180, right? Yeah? Okay, I can assume that. Okay? All right, couple more things. GHK, JHK, this guy, and KHG, I'll go a different color, this guy, are supplementary. So this angle plus that one adds up to be 180. Those are also another linear pair, right? KK? All right, things that cannot be assumed. Lines that appear perpendicular may not be perpendicular, right? So you might think, oh, that one kind of maybe looks like he's a 90-degree angle. Unless they put a box in there, we do not know that that's 90. You cannot assume that. You can assume straight lines are 180, but we cannot not assume that a line, even though he looks like 90, we cannot assume that, right? We cannot assume perpendicular lines. All right, so that's number one. Number one. Angles that appear to be congruent may not be congruent. Number two. So, just because this angle looks like he might be the same measure as that one, we cannot assume that unless they put the little loop-de-doos in there, right? They have to put them in there in order for me to say that they're equal to each other. Make sense? Because one might be 40 degrees and the other one might be 41 degrees. Not congruent, but they look just about the same, right? Number two. Number three, segments that appear to be congruent may not be congruent. So like H, when I said before, H like kind of looks like he's exactly in the middle. It looks like this segment and this segment are the same. But I cannot assume that unless they do this and put those little tick marks in there. I cannot assume that, right? Okay, let's go to a question and then we'll be done. So now looking at this diagram here in example 3, determine whether each statement can be assumed. Can we assume that CE, which is this guy, and CF are opposite rays? Can we assume that those are directly opposite from each other? This guy right here. Are those two going opposite directions making a straight line? Yeah, he makes a straight line. He looks like a straight line. He's going to be a straight line. So yes, he is a straight line. Okay? All right, next. Things that we can assume. BGC, this angle right here, and KGC, this angle right here, are a linear pair. Can we assume that this angle and this angle make a linear pair? Yeah, because it looks like a straight line. Yes, we can assume that. Okay? All right. Next, let me erase. ABJ is this guy. And CKG, BG is this guy. Those are vertical angles. Can we assume that those two blue guys are vertical angles? Do they make two straight lines in between them? Yeah. So we can assume that they're vertical angles, yes. Yes, we can. Okay, BCG, let me erase. BCG is this guy, that black one, and DCF are congruent. Those two guys are congruent. No, the top one even looks bigger than the bottom one, right? We cannot assume that they are congruent unless they put the little things in there. Nope. All right, can we assume that BE and IF are perpendicular? BE is this guy, IF is this guy. They look it, but unless they do this to you, we don't know that for sure, right? They look like they're perpendicular. They look like they're making a right angle, but we don't know that for sure. So no. EBC, let me erase. EBC, this angle here, and CBC, no, GBC, this guy, are complementary angles. This guy and this guy. Complementary means they add up to be 90.
Yes.
This guy looks like he's 90, but do I know that for sure?
No.
Maybe he's 91, right? So they look like they might be complementary, but because I don't know that that's 90 degrees, we don't know that for sure, right? So no. Ooh, we about to the end. Two left. ICH. ICH, this angle. Whoop. And HCD. Those are, what do they call them, adjacent?
Yeah.
Those two, are they adjacent?
Yeah.
They share a vertex, share a side? You betcha, yes, they do. So that guy's a yes. On G. And BC is the angle bisector of ECG. Where's the ECG? ECG. Right here. This green angle, they're saying this guy's a bisector. What does that mean again? He splits them, like he's the midpoint. He splits them exactly into two equal pieces. So basically they're saying, do I know that that guy and that guy are the same? No, not necessarily, right? One could be slightly bigger than the other. So no, we do not know that for sure. Good? Do we understand what we can assume and what we cannot assume to be true? Okay, there you go. There's your homework. All right. 2, 4, 6, 8, 9 problems for homework. Did you say that was a lot of homework? That's 9 problems.
That's a lot of
We're not even double digits. I know, because I make you write them all out. But, you know, if I would have said 4 through 24 by 4, or by evens, that looks shorter.
Yeah,
But it's actually more problems,
6.
right? It would be like 3 more problems than you need to do, right? Whatever. Okay, there you go. Actually, 2 more problems. There you go. All right. Goodbye, people watching this video.